Question 1 to 5, it says there, state 2 conditions needed for collision between 2 molecules to lead to a reaction. Mosi, what did you say? Yes? Oh, sorry? No? No?
They must have sufficient kinetic energy.
Sufficient kinetic energy. Sufficient means greater or equal to activation energy.
The particles must have correct orientation.
Yes, so the correct orientation. And you must have sufficient, and sufficient, we refer to that the kinetic energy must be greater or equal to the activation energy. Sufficient energy. Alright, then it says there, a small heap of magnesium powder tends to burn faster than a small piece of magnesium ribbon. Refer to the collision theory to explain this observation. Leakwe, what did you say?
When a solid is divided more finely, there's an increase in its whole surface area. Therefore, more effective collisions per unit time, thus rate of reaction increase.
Okay, good, but you're missing something. So you copied word for word from the notes, which is fine, but they're asking specifically between magnesium powder and magnesium ribbon. Then you must say magnesium powder is divided more finely than magnesium ribbon. Okay, so just tailor it a bit, change it a bit, so that it fits the question. Okay, so you just need to add magnesium powder is more finely divided than magnesium ribbon. Okay, and then the next one, the energy distribution of reacting particles can be represented by the Maxwell-Boltzmann curve. What is represented by the area under the curve, Bookie?
The number of the particles represented by the area under.
Nee, wag, whoa. The number of particles?
Represented by, it's by the area under this part of the curve. Don't have enough energy.
No, so you copied somewhere, I don't know where. So they ask, what is represented by the area under the curve? Under the curve, they mean the whole thing. There. So there, under it, all of them, that is the, oh, did I write it down here? No, I didn't. That represents the number of particles present in the reaction. So everything. The particles that will react and the particles that will not react. All of them. All of them. Then they ask, which external factor can change the shape of the curve? Briefly explain why this changes the shape of the curve. Chabu.
I'm sure. But I said when molecules do not all have the same kinetic energy at the same time.
Huh? I'm asking, which factor can change the shape of the curve? We have 5 factors. We have state of division, and
The 5 factors.
we have 5 factors. Which one of those 5 factors will change the shape of the curve? It is the temperature. The temperature. Jabu? What does the temperature do? Why does it change the curve? Agnes, Jabu, sorry, princess.
I don't know why, but all I know is that when it is at a lower temperature, and when it's at a higher temperature.
Okay, so let's look at that again. So when it is at a lower temperature, it's higher up, more particles don't have sufficient kinetic energy. And when it's at a warmer temperature, it shifts to the right. So the whole thing flattens down a bit and it shifts to the right like that. Okay, so let's say this one had energy of 10. Now it has energy of 20. This one had an energy of 20. Now it has an energy of 30, for instance. Okay, so the whole thing shifts to the right. Okay, so what I want you to write down there is the temperature. Briefly explain why. An increase in temperature increases the kinetic energy of the particles. Thus, more particles have a higher temperature. Horsey, is this chapter easy peasy for you? Just easy, not peasy.
Yes, just
Okay, while they are writing down, will you help me please? I want to move this thing just there for the open day tomorrow. Wait. Do you think there will be space?
yes. A bit.
Okay, right. Then it says, how does the addition of a catalyst influence the curve? Explain your answer with the aid of a Maxwell-Boltzmann distribution curve. So how will it influence the curve? Is it going to change the shape? Is it going to stay the same? What's going to happen, Mama? Oh, sorry again?
I said it lowers the activation.
Okay, so does it change the shape of the curve?
Yes.
No. It just changes or it lowers the activation energy. So what I want you to draw, would have wanted you to draw, is this thing here where you show the curve and then you show what was the activation energy with no catalyst and then what is it with a catalyst. And they can ask you to draw this. Okay, so you write the Maxwell distribution curve and you show where was the activation energy with no catalyst and with a catalyst. Yes.
Is it okay if we draw all of the factors on one?
That's not what they wanted in this question. They just said show what effect a catalyst will have. So you must then just clearly show where's your effect of a catalyst.
I also showed the temperature as well.
Okay, that was not the question. Let me just see what you drew.
But I also answered the questions.
Okay, then the next question, they ask, use the collision theory to explain each of the following observations. The graph is in your notes. Alright, so they'll ask you to explain the following with the aid of the collision theory. A decrease in temperature decreases the reaction rate. A princess? Question 4a. Yes, a decrease in temperature. What happens? The particles now have? What's wrong?
Nothing.
No, it's obviously not nothing. What's wrong? Huh? Are you scared to tell me?
What's that, Antoinette?
Maybe she's scared for a question. That's what's going on.
Alright.
What's with it?
Princess? No, what happens when you change the temperature? No, I'm not asking the graph. I'm asking with the collision theory. 4a. Yes, Mama.
As temperature decreases, the particle kinetic energy also decreases.
Okay, for that you get one more.
Therefore, less particles will have insufficient kinetic energy.
No, okay, less particles have sufficient.
What's that decrease?
or negative there. Less particles have sufficient kinetic energy, thus less effective collisions per unit time, thus the reaction rate decreases. This was homework for about a week ago. Alright, then the next one, an increase in concentration increases the reaction rate. Siamo? Siamo? Yes? Concentration. Yo. Siamo? Concentration. Yo. Yo, I'm tired of you not working.
Oh, it's concentration increases the more particles increase.
Thus,
Therefore, more effective collisions per unit time, thus rate of reaction increases.
wait. Okay, then the last one, the addition of a catalyst, Antoinette.
Catalyst lowers the activation energy.
Thus,
Thus more thus more particles will have sufficient energy to overcome activation.
thus,
That's again.
yes. So far you will have 2 out of the 3 marks. What's that golden sentence? Thus, more effective collisions per unit time. Thank you. Alright, now they say, in general, a teaspoon of sugar dissolves much quicker in hot water than it does in cold water. Use the graph on the right and your knowledge of the collision theory to explain this observation. Bookie? 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 Question 5 that I just read out loud. Go.
In hot water, the particles get more faster.
First day. Why? What is that sentence that you have to say over and over? Guys. You are 2 lessons behind the Afrikaans class. 2. A solid 2. Okay? In warm water, the particles have higher kinetic energy. Thus, more particles have sufficient kinetic energy. Thus, more effective collisions per unit time. And then you're not going to say thus the reaction rate is faster. Then you're going to say thus it dissolves faster. Again, you're tailoring it just to fit your question. No, you'll get the mark. Okay. Then we get more to the exam type of questions. It says there, a learner investigates the factors that influence the rate of a reaction. He adds 50 grams of zinc granules to 500 cubic centimeters of hydrochloric acid with a concentration of 2 moles. Now, question 6 was not part of your homework. We're doing that together now. Okay? Assume that the zinc is completely covered by the hydrochloric acid. The hydrochloric acid has a temperature of 20 degrees Celsius. The change in concentration is shown below. Okay, and then they'll give you a graph as well. Say again? This was homework and it was easy peasy. You're not even supposed to copy anything. Okay. So if we look there, they say that we have 50 grams of zinc. Our hydrochloric acid is 500 cubic centimeters and the concentration is that. Then you can see there in your graph that you have the concentration of hydrochloric acid versus time. You see the concentration starts at 2, and then it goes lower, 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 lower. But does it go all the way to a finish? No. So it ends there. So there's some of the hydrochloric left over. So which one between the hydrochloric acid and the zinc is our limiting reactant? Which one is the limiting reactant? It will be zinc. Since there's some hydrochloric acid left over at the end, it means it was more than enough. So our zinc was our limiting reactant. Okay. Now they say, write 2 observations for this experiment. And we did this experiment. This is the one where you heated your hands. What did you observe? What did you see with your eyes? You saw bubbles, so you saw a gas given off. So you can write there bubbles or gas given off. Oopsie. Okay, so this is question 6a. You saw a gas given off. You saw bubbles, gas, bubbles. You can say you saw hydrogen gas given off. And what was the other observation? Because they asked for 2.
Temperature.
It increased. The temperature increased, or the beaker gets warm. Okay, then 6b, they ask, define the term reaction rate. Yes, Bookie?
Is it the change in the concentration of products or reactants per unit time?
Mooi. Okay, now you can write it like this, or you can tailor it, change it to fit this experiment. You can see in this experiment, yes, they had the concentration, so we're measuring the change in the concentration of what? Of just the reactants. So you can skip out the word products if you want to, but you don't have to. Okay, then question C, they say there, calculate the average reaction rate for this reaction over 45 seconds. Okay, so Boki just said the rate is a change in concentration or the rate of change in concentration. Say again? Okay, wait. So this formula is not on your data sheet. Now you have to remember it in your brain, and you remember only this. You forget about the negative or positive. Okay, so let's say for whatever reason you can't remember negative, positive, what? Okay, so we have this. What is theta again? It is final minus initial. Okay, so if you look on your graph, what is the final concentration value, Liakwe? Yes, the final one is 0.77. There at the end, 0.77. And our initial one, Mosi? 2. Then our final time, they were 0.77. They asked for 45 seconds. And our initial time is 0. Okay. Jobu, are you on it? Say again. Okay, so you get negative 0. Don't round off that. You can't say 0.3. That is 0.27. There we go. Thank you. All right. Now, this answer cannot be a negative. Now you're like, oh, and now remember it can't be negative. The only thing that you do is you say, let me put a negative in there and in there, and then this becomes a positive. Okay, now we need the unit. You can see what was the unit for concentration again? Moles per decimeters cubed. And for time, in this instance, it was seconds. It's not always seconds. Sometimes it's minutes or whatever. This instant, it was seconds. So you're going to write there mole per decimeters cubed per second divided by seconds. Okay. Then they say, how will the initial rate of reaction change if the following changes are brought about? Right? Increase, decrease, or remains the same. Okay. They ask, what will happen if you increase the temperature to 30 degrees Celsius? Mama? Wait. Okay. Then, Princess, what happens if you use 600 milliliters of 2 mole hydrochloric acid instead of 500? How do you know it stays the same? The moles are still the same. Okay? Remember, the 5 things that can change the rate, is the type of substance you have, whatever. It is the surface area. Oh, we're not at catalyst yet. I'm looking at number 2 still. Okay? It is concentration, it is temperature, and it is the catalyst. Okay? Those are the 5 things that can change the rate of a reaction. Is volume any one of them? No. So at question 2, what did they do? They changed the volume. The volume changed to 600 cubic centimeters, where it was 500 cubic centimeters. Okay, so they changed the volume, but that is not one of the things that can change our rate. They are going to try to trick you with this one. They always have it somewhere in the exam. Okay, Princess, are you with me? Because Mama gave you the answer there. I tried to explain to you now. Okay, and then the third one, they say if you have copper sulfate as a catalyst, Tiamo? If you have a catalyst, what will happen with the rate? It will? A catalyst decrease. No, don't listen to her. What will happen? When you add a catalyst, will it go faster or slower? It will increase. Okay, then I want you to go into this book of yours. Okay, and I actually want to do a few of them. But the time. Okay, so what I want us to do together, okay, I want you to quickly go to page 60, please. Sorry, no, before you go to page 60, I first want you to go to page 48. 48. Okay, so if you look there on page 48, you will see there they give you all the definitions, all the different types of formulas, different units, practical skills, how do you measure different things, and. Now you can go through all of that for your practical. I did send on your WhatsApp group. Your practical, we will do together in class on Monday afternoon. In that extra classes time, we're going to do the practical. I've decided so because I don't want to waste any more time. So we're going to do it after school, and then the Tuesday in class, you're going to write the test. Okay, so the practical Monday on this chapter, and Tuesday you write the test in class. Okay. Now, you can go through page 48 and 49 for that. Then on page 50, you can see there they gave you a summary of the different types of graphs for the Maxwell-Boltzmann curve. Yes? Okay, and then also on page 52, Okay, and then on page 53 you have all your definitions, and then it starts with the past papers. With the past papers, I first want to look at page 60, did I say? Yes. Page 60, question 11. Page 60, question 11. Now that is one of the practicals that you're going to do on Monday. Well, I'm going to do it in front. Some of you will assist me in it, but we're going to do it together. You're just going to write up stuff. So there you see is the experiment. It's between sodium thiosulfate. Question 11. Question 11. Sodium thiosulfate and hydrochloric acid. And then it gives you sodium chloride. What's another name for sodium chloride? Salt. Table salt. Okay, so salt in water, you don't even see it. Then you see it gives you water. It gives you sulfur dioxide. Sulfur dioxide is a gas. You will smell the gas on Monday. It stinks. And then we have sulfur solid. Now sulfur solid is a yellow powder. Okay, so what will happen when you add the two together, you can see there's a little drawing. We're going to have this Erlenmeyer flask, and then we're going to have a cardboard with a cross. Then you're going to see it changes to a yellow color, and then all of a sudden the cross will be gone. Yes, Mama?
Okay, why does sulfur doesn't dissolve in water? Why doesn't it dissolve in water?
It is because it is a non-polar powder. Non-polar substance does not dissolve in polar stuff. Grade 11 work? So it just doesn't dissolve that well. Alright, then it says in the first experiment 50 volumes of sodium thiosulfate is added to so much hydrochloric acid. And then over a piece of white paper with a cross, the hydrochloric acid is in excess. Then the time taken is given. Alright, and then the experiment is recorded 4 times with 4 different volumes of thiosulfate. The results shown below. Okay, right, so if you look there at the table, you can see there's 5 experiments. What happens there, when they change the volume of sodium thiosulfate, check the volume of water. Okay, so you can see what they've done is sometimes they added no water, so then it's very concentrated, and sometimes they added a lot of water and then it's very diluted. Do you see that? Tiamo, kyk. Okay, so what they did is they changed the concentration of the sodium thiosulfate. Okay, and then you can see it goes slower as they diluted it more and more and more. Right, now they asked to find the term reaction rate. That's it. Then they ask, how does the concentration of sodium thiosulfate solution used in experiment 2 compare to that used in experiment 5? Choose from more than, less than, or equal to. Antoinette, if you compare 2 with 5, which one's concentration is higher, 2 or 5? Two. So 2 is, the concentration is more than, the answer there. Then they ask you to draw a graph on the graph paper. We don't have that now. Use information in the graph to answer the following questions. Okay, blah, 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 blah. I'm not going to go into that so much now. So, if they ask you to explain that, you're going to say, all right, that one's concentration is higher, thus more effective collisions per unit time, thus the rate of the reaction will be higher. Yes?
Yes, ma'am.
Okay, thank you very much. Okay, now I want you to check at question 11.6. They say there, the mass of sulfur produced in experiment 1 is so much. Calculate the mass of sodium thiosulfate used in experiment 1. Okay, so this is where we're going to use the mole table. You remember that from last year? Yes. Okay, so that is what I want to practice, hopefully 2 to 3 times today. So somewhere in your writing book, I want you to write, we are now on page 60. This is question 11. This is March 2018. Okay, and we are at question 11.6. Okay. So with the mole table, you always start with what?
Yes.
No, your before that formula. Thank you, Bogey. So we have the sodium thiosulfate. It reacts with hydrochloric acid. It gives you sodium chloride and water and sulfur dioxide and sulfur. Okay, and the reaction that they give you is already balanced. So you write down your mole ratio underneath. And you highlight that with a color because that is your recipe. How many 5 rands did I just collected here?
5, 15.
Alright, it's not a comment, it was a complaint. Alright, now they tell you there that you get here the mass of sulfur that is produced is 1.62 grams. That is the mass. Okay, and they want to know what is the mass of sodium thiosulfate. Are you allowed to fill in mass in this table? No, only moles. Alright, did they say anything regarding hydrochloric acid? They said hydrochloric acid is in excess, and they said that in capital letters, in excess. So it means it's too much. I'm not even going to look at that. I'm not going to even waste my time there. Did they say anything regarding sodium chloride and water and sulfur dioxide? No. So I'm also not even going to look at that. Okay, and then there's 2 more pieces of information that I can fill in. Since hydrochloric acid is in excess, it means this one was the limiting reagent. What does that mean? It means we use all of it. We have 0 of it left at the end. And since sulfur is a product, we know we start with 0 of that. Yes.
Remember last time we had the E, I think, in the triangle.
Yes, beginning, change, end. You still want it there. And this is your mole ratio. Okay, so we are there. What are we going to do? Anyone? Plan of action. That's 1.62 is the mass of sulfur that we have at the end, and we want to know what do we have here. Yes, okay. We'll see. Moles of what? Sulfur. Okay, good. So we're going to take that mass and we're going to calculate the mole. Now please write down these formulas. You get a mark for them. Okay, we want the mole. The mass is 1.62. The molar mass of sulfur you find on the periodic table is 32. Sulfur is element 16. Is it 32? Okay, so that gives you 0.050625. It's not my final answer, so I don't round off just yet. Okay, so that is the mole of that at the end. Okay, we started with 0. We have that at the end. So obviously we've added that. Okay, then I use my mole ratio to see how this changes. If my mole ratio is 1:1 and I gain so much, how much did I use here? The same amount. Minus 0.0506 blah 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 blah, and since I have 0 at the end, this is how much I had at the beginning. Okay, now what? Huh? No, we don't have to say the reason. This your mole table is your reason. If you don't have a table, then you have to show me that the ratio is 1 to 1. Okay. What now? What was the question again? Calculate the mass of sodium thiosulfate. We want this one's mass. There. Thank you very much. You're just going to use the same formula and say, alright, now I'm going to look at sodium thiosulfate. The mole, we just got that. We want the mass. The molar mass, what's wrong? The molar mass is, sodium is 23, I think. 23 times 2 plus. Sulfur is 32, so 32 times 2 plus 3 times 16. So now you're going to multiply, right? When you take it to the other side. Is there someone that works slower than you, Mama? You write very slow. Good job, but you can't speak. Alright, what did you get? 7.9988 blah 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 blah, so 8 grams. If you round that off. Say again? Yes, you can. I did not say she's a slow learner. I said she writes slow. Okay, guys, focus here. If you look at the answer, you see there that the answer is 7.9 grams. For answers like this, because they probably rounded off here and we didn't. Okay, there will be a range. They'll take from 7.8 until 8.1, for example. Alright, now I want you to please go to page 62. Okay. Now, I'm going to give you homework while I've just set the time with Catherine. We're going to do page 62, question 13 together. Your homework that I want you to do, I just want to check, is it forward or is it backwards? Your homework. Have you done this at the extra classes? Wow. No, I'm looking for a percentage something. I think it was question. Yeah. I want you to please do for homework question 1. Question 1 on page 54. 54. Okay, so we're going to do together question 13. Okay. Right, so at question 13, they give you the reaction of zinc with excess hydrochloric acid. So again, hydrochloric acid is in excess. Then they say they did different conditions, reaction conditions, shown in the table, and then we must now look at the questions. Okay, so if you look there at the table, then they give you experiment 1, 2, 3, 4, 5. Let's just look at all of them. If you look at the concentration, you see that okay, toe maak, jy trek dit om. Okay. If you look there, let's look at the first one. sorry, the first column. The concentration you can see there. Some is 2, some is 1.5, and then there's one that's really big. It's experiment 3. It's 5. Okay, so we think that one, if it depends on concentration, will be the fastest. Then we see the volume. Will volume have an effect? No. So there they try to trick you. You can see that experiment 4, the volume is bigger, and there will be they'll try to catch you. But you know now you are more clever than that. Then the state of division, you can see powder, granules, powder, granules, powder. Which one will react faster? Powder. Then you see the temperature there, 25, 25, 25, except for the last one is 35. So that one will react faster. And then you see there's the rate, the reaction rate, 7, 14, 5, X, and 4. Now those, experiment 1 and 5 are compared. Let's look at 1 and 5. 1 and 5, the concentration is the same. The volume is the same. They are both powder. It's the temperature that is different. Okay, now they ask, write down the independent variable. The independent variable is the thing that we change. What did we change? The temperature. What will the dependent variable be? The rate. The thing that we measure, we looked, which one is faster? Okay, so the independent variable, are you writing down? There is the temperature. Then they ask to find reaction rate. Boki?
It's changing the concentration of reactants or products per unit time.
Right. Then 3.3. Write down the value of X in experiment 4. Like how must we just make up a time? This is weird. What we're going to do is we're going to see which one is 4 very similar to. Okay? So if you look at 4, the concentration is 1.5. 2 is also 1.5. The volume is 200. Ooh, this one is 400. But let's go on. This one is granules, 25, 25. So 4 is similar to 2, except for the volume. Will the volume make a difference? No. So what was 2's time? 14. So what is X? Also 14. Okay, so the value of X is 14. Then they say there, the Maxwell-Boltzmann energy distribution curves for particles in each of the experiments 1, 3, and 5. That one cut off. 1, 3, and 5 are shown alongside. Identify the graph ABC that represents the following. 3 and 5. So they are basically saying you're comparing 1 with 3 and 1 with 5. Basically. Okay, because we must say what is 3 and what is 5. Okay, I think that's what they're saying. No, let's just see. They're not saying that, sorry. They're not saying that. If you look at this curve, okay, you see 3 curves there. Which one looks like the normal one? Like nothing weird changed there. Alright, I would say A. Why? Because A and B is similar. The one is just bigger than the other one. And then what happened to C is the whole curve shift to the right. So there's something changed. So I'm going to take A as my base, I think. Okay? They say I must compare 1, 3, and 5. Let's think. 1, 3, and 5. 2, 5, 2. So 3 has a higher concentration. How will that affect the graph? How will that affect the graph? Yes? What do you mean with widen?
Like C, when we see A and B.
It's not C. Yes, it will be shorter, but how will it affect the graph? In here, there's no time. Can you see that? What is the area under the graph again? The number of particles. If you compare A, there's so many particles, and B, there is more particles. Can you see that? Okay, so B has more particles. What is more particles? A higher concentration. So if we had to compare 1, 3, and 5, you see 3 has the highest concentration. So 3 fits with B. So that one is 3. Okay, now let's go on. Let's go compare 1 and 5. The concentration is the same. The volume is the same. The powder is the same. It's just the temperature. How will the temperature affect it? It shifts to the right. So C fits with 5. So A is 1. Okay, so they asked there, which one fits with experiment 3? We said that is B. And they asked, give a reason for your answer. You're going to say what happened with experiment 3. There was a bigger concentration. So you're going to say bigger concentration means more particles. That's a bigger graph. Okay, 13.4.1. That means a higher concentration means more particles, meaning bigger graph. Okay, 13.4.2. Experiment 5. Okay, why did we say C? Because experiment 5 has a higher temperature. It's a higher temperature, and that means that the particles have a greater kinetic energy, so it shifts to the right. Shifts to the right. Okay, so you know now what your homework is? Question 1, please.